Compare fractions word problems. Once again, we do have to be able to pull problems out of text. Yes, out there in the real world, when you're solving real world problems that come up, you're almost never going to get those problems presented to you as a series of equations. You're much more likely to get a problem expressed to you in words, and you have to figure out what information you need and what information the problem is giving you. So, let's take a look at these word problems and approach them with an open mind and no fear. Because I know that fractions and word problems separately are two phrases that make a lot of grown adults wake up in the middle of the night in a cold sweat. I get it, no judgment. Let's see what we can do here. Mrs. Smith made a table to show the hair colors of the students in her classroom. Which hair colors represent less than 1/4 of the class? So let's take a look. This is the same kind of thing we've been doing. We just need to take each one and compare it to 1/4. 1/8, for example, I know is less than 1/4. How did I know that? Because the numerator is the same, there's one of them, but the denominator is bigger for the 1/8. An eighth is a smaller piece than a fourth. Again, think about pizza. If you had a pizza in front of you, which is bigger, taking a fourth of it or taking an eighth of it? 2/12 is a little bit tricky, but if we recognize that 2/12 is 1/6, then by the same logic, we know that it's less than 1/4. I hope you followed that. 2/12 is the same thing as 1/6, which is less than 1/4. 1/3 has a smaller denominator, and again, I know that it's a little bit counterintuitive that a smaller denominator would mean a bigger number, but it does make sense when you look at it in terms of division and when you look at it in terms of cutting things up. If I cut a pizza into more pieces, each piece is going to necessarily be smaller. I really hope that makes sense because it's very important and it's a very foundational principle in fractions because it helps highlight the fact that multiplication and division aren't really two separate processes. They're really the same process done in two different directions. 1/3 is greater than 1/4, specifically because 3 is less than 4. Cutting something into 3 pieces means each piece is bigger than cutting something into 4 pieces. 2/6 is the same thing as 1/3, which we already determined is greater than 1/4. So it looks like the ones that are less than 1/4 are blonde and redhead. Blonde and redhead are the ones that are less than 1/4. Onward. Pam bought different drinks for a party she was throwing. After the party, she had the following drink amounts left over. She had one. Wow, this is not well. This is an ugly problem. Look at that. They're all overlapping. Okay. So she has a 1/2 liter of soda. She has 1/5 of a liter of water. Okay. I mean, I guess it's not tap water. And 8/10 of a liter of apple juice. Which statement correctly compares the amounts of the two leftover drinks? So for right now, we're going to take a look at these three, see if we can figure out which one's the biggest, which one's in the middle, which one's the smallest. I'm going to say, just based on all the patterns that we've been looking at here, 1/5 is going to be the smallest. So 1/5 is less than 1/2. And again, should make sense because what? 1/2 has a, again, lower denominator. Cutting something in half means each piece is a lot bigger than if you cut it into fifths. And that's going to be less than 8/10. See if you can figure this out with me. If I have 1/2, if I instead cut a circle into tenths and I shaded half of it, that would be 5/10, which is less than 8/10. So let's see what the problem's actually asking. Pam had less soda left over than water. That's not true. She had more soda left over than water. Pam had more soda left over than juice. Also not true. There is more juice than soda. Pam had less water than apple juice. 1/5 is definitely less than 8/10. So the answer is going to be C. Next question. Katie made a table to show how much time she spent on homework last week. Now I know, again, tangent time, I know that these particular problems don't seem very realistic. And that's true. You're not going to really get a kid who's logging their homework in fractions. If a kid was going to be responsible enough to log how much homework they do each night, they would probably do it in minutes, not in fractions of an hour. But again, the idea is to get used to using these topics, to get used to using these ideas, and putting them into this context. It's a lot more difficult to use real-world numbers because real-world numbers tend to be ugly and messy. Now, again, I don't know that this exact problem is super useful because I feel like students would look at this problem and roll their eyes and go, see, this is why math isn't useful, because they don't realize that they're taking two separate skills, interpreting a word problem and working with fractions, and they're kind of awkwardly showing them or shoving them together so that you can demonstrate both at the same time. Not the most elegant of problems, I admit. On which activities did Katie spend more than 2/3 of an hour? More than 2/3 of an hour. Okay. Well, let's look at each of these. Are there any of these that I can throw out right away? I know that 5/10 is 1/2, right? 5 is half of 10, so 5 divided by 10 is the same thing as 1 divided by 2. 5/10 is equal to 1/2. That's definitely less than 2/3. Right? We've seen enough examples of 1/2 and 2/3 to be able to visualize in our head without having to draw it that 2/3 is bigger than 1/2. And in fact, 3/6 is also equal to 1/2. That's also less than 2/3. So far, so good. 7/8 and 3/4 are each greater than 2/3. And I would challenge you to pause the video at this time and see if you can work out how I did that, how I knew that, based on what we've done up to this point. I've shown many different techniques. I've demonstrated many different example problems. I think at this point, you should be able to figure out why those two are greater than 2/3. But for now, let's see if I'm right. By the way, just looking at this, 1 hour, oh, it was in a week. Okay, I was about to say, if this is one night worth of homework, that's a lot of homework. 1 hour, almost 3 hours, like 2.5 hours total, if I'm estimating right, of homework. Not unreasonable in a week, definitely unreasonable in one night, especially, for 4th graders. Moving on. John has 3 colored ribbons. A red one that is 2/5 of a meter long, a yellow one that is 1/10 of a meter long, and a blue one that is 4/5 of a meter long. Now, I love multiples of 5 and 10 because they are so easy to work with. In this case, we can absolutely get all 3 of these into one common denominator fairly quickly and fairly easily, unlike the last problem. The last problem, you would have had to do a little bit of working to try to figure out which one was bigger and smaller, but in this case, I know that we have red, which is 4/10, right? 4/10, 2/5. Again, at this point, hopefully you can follow me through this. We've got a yellow ribbon that is 1/10. And we've got a blue ribbon that is 4/5, which is the same thing as 8/10. So with this information in mind, we should be able to answer the next question pretty quickly. Is the yellow ribbon longer than the blue ribbon? No. Is the yellow ribbon longer than the red ribbon? No. Is the red ribbon shorter than the blue ribbon? Yes, in fact, it is exactly half the size of the blue ribbon. If they are each cut into tenths of meters, this red one has 4/10. This blue one has 8/10. It has twice as many tenths and therefore is twice as long. Not bad at all. Moving right along, that was compare fractions word problems. We're making great time. Let's continue.